These questions are on dynamics, first part of the chapter, the Newton laws, and I'm doing question number 10. Two suggestions I got, and the force is given to be, there's a mass is 320 kg, and now you have to find it. I got one suggestion, which is B, but I need other people to participate in it. Let me know the answer if anyone can divide it. Hmm. 6.25 10 power minus 7. So uh, answer is B. A resultant force causes a body to accelerate. What is equal to the resultant force? Resultant force has a formula. Resultant force is equal to ma. What is equal to the resultant force? The acceleration of the body per unit mass. What is the definition of the force? By definition, force is the change in momentum per unit time. This is actually Newton's second law, official definition. A ship of mass this much kg is approaching a harbor with a speed 6.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? We have the force, we have the mass. We can first find the acceleration. We first find the acceleration, and then after finding the acceleration, we can use the formula A is equal to V minus U upon T. So T is equal to V minus U upon A. This is the initial velocity, and stop means final velocity is 0. 7.7 10 power 13. Theoretically, it is the stopping force. So I'm putting a negative there. This answer should be checked. The answer for acceleration, please verify this answer. Is it really 7.7? 10 power 13, because it's looking to be too high. So please, everyone, others should also check the calculation. 9200,000 upon 10 power 7. So I think the answer needs checking. Check the calculation for acceleration. Zero point 0.0109. That's right. Right, no, thank you. So that answer makes sense. Other people should also contribute. Keep your calculator with you. You can use any calculator. Mobile version is also fine. So we are working here, and I need answer for my next calculation. One four nine seven 1497 second. The option is not matching, so divide by 60. Divide by 60. Let's see how much it become. 1 4. So do this calculation. See, one, but 1504. But answer is slightly different, but overall it should be close to, overall it should be close to C. But other people should also contribute. Slight difference will always come, that depending how many digits you are taking. But whatever Noor you are getting, convert it into minute and then let me know. Even I'm getting a slight different answer because it depends upon the number of places. It depends upon the number of decimal places here. Actually, the difference is coming from this position, the acceleration. No, whenever acceleration is decreasing, whenever something is stopping, whenever something is stopping, acceleration has to be negative. Whenever something is stopping, it has to be a negative acceleration. Yes, because velocity, magnitude of the velocity is decreasing. A tractor of mass 1000 kg is connected by a tow bar to a trailer of mass 1000 kg. The total resistance to motion has a constant value of has a constant value of 4000 Newton. 1/4 of this resistance acts on the trailer. As I mention always in my class, please use your topical books. Either you have taken from your college, from me, from any other resource, any digital resource, but you should solve on your book because A-level MCQs, theory questions are so many that if you do not keep a record, you won't actually be able to work a lot. Otherwise, you will be doing some questions again and again. So keep a record, use a past paper book. Any past paper book is fine, but it should be containing all questions. So a tractor of mass 1000 kg is connected by a tow bar to a trailer of mass 1000 kg. The total resistance to motion has a constant value of, so I have a trailer and I have a tractor, I have a, the quarter of this resistance, the 1/4 of this resistance acts on the trailer. Total constant value is 4000 Newton. When the tractor and trailer are moving along horizontal ground, now it's a very important thing, speed is constant. Speed constant means forward force is equal to backward force. There is a tow bar, so I connect the tow bar and it is having this tension. This is my forward force. Tractor is going, this combination is going forward with constant velocity and zero acceleration. Total mass, one object is 1000 kg, other is also 1000. 1/4 of this resistance acts on the 1/4 of this resistance acts on the trailer. Both are 1000 kg. This is quarter. So it will be experiencing 3000 Newton backward force. I have drawn the diagram as mentioned. Please work with me. Do not worry about the number of questions. Work, proper work, and then see your understanding will improve. Some people just follow that you have to do 30 questions or 20 questions. That will come, that will occur. But do the question with full understanding. Now, when the tractor and are moving together, speed is constant. So forward force is equal to backward force. What is the force exerted on the tractor by the tow bar? So he's asking for this force. Now, I have made the diagram, solve it. This is Newton's third law. Another hint. This question is according to Newton's third law. If something is moving at a constant speed, forward force is equal to backward force. Now the trailer is getting a force. The trailer is getting a force from of resistance 1000 Newton. If the trailer is receiving 1000 Newton backward, it must be applying 1000 Newton forward, and that is why it will be applying the same force on the tractor. So I now isolate the backward object, and this is my back object. It is getting a force of 1000 Newton. This is the tow bar, and then this is the tension, and tension will also be equal to 1000 Newton. If an object is moving at a constant speed, the forward force is equal to backward force. No, it is the concept of driving force. Let me share a concept that this is a tractor and it is taking a trailer. It is pulling a trailer. A tractor is pulling a trailer. So X is the driving force. X is the which is taking everything forward, and tension is backward. Tension is equal to backward on the tractor. Now, this is a very important concept to understand, that when you make a string, I explained this concept when I was doing this topic in my class, that a string has two tensions. One tension coming from one edge and second tension coming from the other edge. So in a tow bar, there are two tensions. Now the backward object, the trailer, is applying a force on the forward object which is pulling it, and that is how it's moving at a constant speed. So forward force is equal to backward force. Now I'm doing question number 29. But better try to understand it here, na. Zara, why you want to have it? I will share it, inshallah. But better to try participate in live, because recording will be there, inshallah. But everyone who is in the class, some people are actively participating, but some people are not. So please participate. Remember the A-level MCQs, paper 2 questions, even paper 3 are qualitative when you are practicing. It is not important how many questions you finish in 1 hour. It is important how you finish it without looking the marking scheme, making your clear ideas. Do not run after the answer that is required. A tennis ball is dropped onto a table and bounces back up. The table exerts a force on the ball. It's a reaction force. Which graph best shows the variation with time t of the force while the ball is in contact with the table? Okay. Saad is saying it is D. The force should be constant. I need logic. I do not need answer only. Okay. One answer got C. But answer is not the year number is marked. Answer is not a challenge. You can always check it. Year number, paper number, variant, everything is marked. I need help. How you can answer on the mic also, but how I get C or how I D means, let me discuss D. D means that force is constant. C means that force, here the force increases and then force decreases. I'm getting answers only, but no one is actually giving me the answer. Actually, I don't know, but why force should be constant? Because when a tennis ball is dropped onto a table and it bounces back up, the table exerts a force. The input force is not constant. It will, just like when you hit something or something hits you, the force cannot be constant. The force increases and then decreases. So logically, when you can see yourself, if you are running and you hit someone or a ball hits you, you feel it. The force increases when you hit, and when you detach, the force decreases. Force cannot increase at a constant rate. Force has to decrease. It's a concept of collision. When you play carom board or anything, you just imagine when you hit something, the force will increase and then eventually it will decrease. Force cannot be constant. So in every collision, like two vehicles collide or anything collide you, or you hit a ball, when you hit a ball, you can check it yourself that when you hit, when the contact start, the force will increase. But when the ball begins to move, the contact drops and the force will decrease. A resultant force of 10 Newton acts on a body for a time of 2 seconds. Acha, this one C. The people who are answering. No, actually, when you draw an acceleration time graph, remember that it is the resultant force. Make it clear. Always people have a confusion between resultant force and one force. Suppose you hit something by a force of 20 Newton. It is not necessary that it is the resultant force. Presently, he's talking about the force while the ball is in contact with the table. I make a diagram here. Look, this is the table and the ball is coming. This is the ball. The ball comes down and hit the table. When the ball hits the table, the ball gets an upward force. It's a transition. The ball apply a force which phase out. The table will apply a force which also will phase out, because energy is not continuously available there. The contact has to finish. So that is why C is the right answer. Force will increase, and as the ball begins to rebound, the force will decrease. This is a famous question, and many people got it in trouble when actually this is on momentum. Presently, I'm doing questions on Newton laws, and I can try this question. Water is pumped through a hose pipe, at a rate of 90 kg per minute. It emerges from the hose pipe horizontally with a speed of 20. 20 multiplied by 90. I think the same that this is a question on momentum. Everyone in the class present here have not done momentum with me, and I'm also getting it. I'm also getting the answer by momentum. But presently, I'm not doing question on momentum as my work always. I always prefer that we do one topic and I got this question now. I left that question because of momentum 35. A man weighs 240 Newton on Mars where the acceleration of free fall is 4. On the moon, G is 2. Which statement is correct? We have a formula W is equal to mg. I can make a ratio formula because mass is constant. W1 upon W2 is equal to G1 upon G2. Remember that mass is a universal constant. So this is my W1. This is my G1. On the moon, it is G2. Okay, so I will take it 240 upon W2 is equal to 4 upon 2. W2 is equal to 240 upon 2. W2 is equal to 120. Okay, Saad is saying answer is C. I have shown full working, and this should be a habit for everyone that you should try to do all the working. It's like solving a proper question when you're solving an MCQ. Other people should also contribute. C. $39. What is a reasonable estimate of the average gravitational force acting on a fully grown woman standing on the earth? Average gravitational force. So he's talking about weight is equal to mg. So if I use the formula, W is equal to mg, so you can take the mass. You can estimate the mass of a grown-up woman. You can take it. What mass should I take it? Because the data looking here, that assuming, let's suppose G is 10 for simplicity, because as this is a question on estimation, so I can say G is equal to 10. If zeros are removed, it means that this is a 6 kg female and this is a 25 kg female. This is a 35 kg female and this is a 65 kg female. Two people are favoring D. Sahi. Because this is a reasonable estimate. Air resistance is negligible. Fired vertically upward, burns down and produces a constant upward force on the rocket. After 5 seconds, there is no fuel. When the fuel is over, air resistance is not there. It will go by inertia under gravity. It will be being opposed. So after fuel is burned, acceleration will become, after fuel is burned, acceleration will be G. So if this is the surface and this is the rocket, it is fired upward. And let's say this is the barrier of 5 minutes and it's moving upward. After 5 minutes, there is no air resistance, there is no engine power. So acceleration will be equal to G after 5 minutes. It can't be zero. It will decelerate definitely and come back. So I have an option A or C. Before the engine power is off, engine is pulling it upward. You people must have seen the rocket launch videos, rocket launch by a very high acceleration. It is not constant. Resultant force is increasing, the fuel is being burned as C as engine does not immediately stop. Acceleration cannot be constant, definitely, because acceleration is constant when resultant force is constant. As he says, the produces a constant upward force. That's right. As a rocket, you can see here, which Noor is pointing out, the rocket is facing a constant upward force, but the weight of the rocket will be decreasing. Why the weight of the rocket will be decreasing? Because its resistance, because the fuel is being burned. Newton's third law of motion is often summarized as every action force has an equal and opposite reaction. A book rests on a table. If the weight of the book is the action force, what is the reaction force? Weight of, remember that the reaction of weight will be the reaction of weight will be another weight. I got 2-3 answers, but all people are still not participating. So yes, no, you're also right, and Afra is also giving the right answer. Both forces are acting simultaneously, not one. Actually, they act simultaneously, but they do not act on the same object. So if this is the table and this is the book, then the book and table are both applying forces on each other. The table is pulling the book downward, and the book is pulling the table upward. So actually they are applying force on each other, but the forces are not acting on the same object. A wooden block is freely supported. Now this is the question 48. A boy throws a ball vertically upward. It rises to a maximum height where it is momentarily at rest and then falls back to its own. He says no, ignore air resistance. So if I throw something upward and I'm saying no air resistance, then obviously for the upward motion at the highest position, the object comes to rest. Okay, I have a difference of opinion in this question. In one episode, it is going upward. In the same episode, it is coming back. If an object is going upward, velocity will be decreasing for the upward motion and velocity is increasing for the downward motion. But acceleration will be minus g throughout the motion. If I take upward velocity plus, I have to take downward velocity negative. Remember this concept. Many people make a mistake here from the O-level background, that when something is going upward, acceleration is minus g, and when something is coming down, acceleration is positive g. Theoretically, it's right. But if in one episode, if the object is going upward and the same episode, object is coming down, then remember that acceleration is not negative, not positive when it's coming down. Acceleration is negative throughout the motion. I repeat the concept before closing. Remember that if air resistance is negligible and an object is going upward and downward in one episode, acceleration is minus g at maximum height. That is a known concept. At the maximum height, acceleration is never zero. But here you should remember that for the upward and downward connected motion, A is equal to minus g. So we have marked this question. This was a good question for our understanding a very technical concept. So we stop here and we will inshallah continue in our next class.